Hello YouTube, RJ. Hey, welcome back to the LARCSET build part 3. This one we've got the radio built, but we ran into a problem at the end of part 2 of this. We don't seem to be getting modulation through to the power section. When I was setting the bias voltage, I got the current up to where they wanted. They wanted 350 milliamps keyed with no audio. Then you were supposed to speak into the mic and it should have went up to 0.6, 0.8 amps. We weren't getting that. So I ended the video and said, hey, we'll pick up troubleshooting. So here we are back on the bench. We've got it out. We're going to do some troubleshooting on this thing and figure out what's going on. Now I'm using my 3D printed home built mic that I built for a previous forehand radio. It's the same type of mic cartridges in there for the most part, other than I tweaked it a little when I was on my other radio, because I found I bought a couple different, these things are cheap. I bought a whole bunch of them. I tried different ones and I found one that sounded better, gave me a better frequency response, and gave me a little more oomph, which his radios tend to need. So I have no reason to believe this isn't working, but just to be sure, we're going to do a quick test. I looked at some postings on the LARCSET, and I found someone with a working unit. Someone else was having modulation issues, and he said he thought it was to do with his microphone. And the guy said, well, it's easy to check. He said, I'm getting 50 millivolts out of my mic, and the first stage of amp is giving me about 200 millivolts. Well, I read that and I thought, well, that seems odd. Looking at that first stage, I would have expected quite a bit more drive than that. Here we are. We're going to see what we're getting. So the first thing I'm going to do is I've got the schematic up here, and I can see that the mic feeds in through a coupling capacitor C66. And I'm going to go ahead, and I've got my scope set up. I'm going to go ahead, take the oscilloscope, and I'm going to try to find C66 here and get on it, and I'm going to see what kind of voltage I'm getting when I'm modulating. I'm being dumb already. I need to get a dummy load hooked up here, so give me just a minute. I'll be back. We'll get a dummy load on it, and we'll start working on this. Okay, I'm back. That was kind of dumb. I meant to get that hooked up. I was putting things together on the bench, meant to get that hooked up ahead of time. I'm glad I noticed that. So I've gone ahead and done that. Turned on the radio here. Let's get back on our C66. Where'd you go again? He's right here. So I should be on right where the mic's coming in. Audio. Probably almost 100 millivolts. So I'm definitely getting enough drive from the microphone. That's definitely not the issue. Let's go take a look at Q18. I'll pop up here real quick and let you see what I'm looking at schematic. Okay, Q18, as you can see, C66, the mic comes in, drives that stage. It's a 2222A surface mount, and it comes out and outputs on C63. So let's jump on C63 and let me see what I see there. So I'm looking for Q18 right there. C63 is right there. So let me get right there. All right, let's see what we get there. Audio. Interesting. I'm getting, I don't think I'm getting any more than I'm getting coming in on the mic. So let me get back on the mic. 194 millivolts average on my scope. And yet if I go to the output of that amplifier stage, I'm averaging 153. Now that don't seem right. So let me think about this a minute. Let me look at the schematic, see if I'm doing something wrong or whatever, and we'll come back to that. So right off the bat, I think we got an issue there. The other thing I might do is, while I'm off camera, I might rig me up a jack to plug in that I can put my signal generator through, so I can generate a very steady tone to test with, so I'm not getting variations from me whistling and such. So let me set all that up, look over the schematic, think about it a minute, and I'll be back and we'll continue on, working through the troubleshooting. Okay, I'm back. What I've done is I made up a cable and I've got it hooked up to my signal generator, and I'm putting out a 700 hertz tone, or signal should you say, at 80 millivolts peak to peak. And so what I want to do is I want to check now again and see what kind of readings we get on this thing. So turn it on, make sure the current looks good. We're pulling about our 350 milliamps, which we're supposed to. That's bias current. So I'm going to jump in here. I'm going to go back to the microphone input and turn my signal generator on. And so get back on the C66. And I'm seeing roughly 100 millivolts, 110, 115 millivolts, peak to peak. So now if we come over here to C63, which is the output of Q18, you would expect to see quite a bit of amplification at that point. So let me jump on there and see what I see. Okay, I'm getting 200 millivolts. That's hardly any amplification at all. I would expect quite a bit more. I'd expect maybe tenfold increase in signal at this point. Let me jump to the other side of the capacitor. Oh, and it drops down to like 60 millivolts at that point. So I'm not sure whether we've got a problem in the amplification stage, whether the transistor's bad or what, or whether we got something drawing it down over here. It's not right. First thing is give me a minute. I'm going to jump over to the computer. I'm going to throw together this little amp circuit on LT-Spice, and let's see, if we put in a given signal, what we should expect coming out, and see what kind of amplification we should be looking at, and then that'll give us an idea if we, if there is maybe he set this up as a buffer stage. It's really not amplifying; it's just buffering the mic. Let me jump over there and do that, and I'll be right there. We'll take a look together, and then I'll know what to do from there. Okay, so let me pop up the schematic and let you see the schematic here of the microphone amp, microphone preamp for the LARCSET. And then you can see I've recreated the exact same circuit. I've got the microphone putting in 50 millivolts, and I've got 11.7 volts coming into the circuit. Here's our output. And so let's simulate this rascal. Let's zoom in here on an area. And the yellow is going to be our mic. And you can see there's quite a bit of amplification from this circuit. I mean, we're pushing close to 500 millivolts. So we're almost 10. I kind of figured probably ought to see about 10 to 1 out of this. And it looks like this amp should be providing us a 10 to 1, roughly a 10 to 1 amplification. So where's my amplification? Why, when I come out and read on this capacitor 63 right here, why am I getting barely any amplification through this stage? And also, why am I getting so much less on this side of the capacitor? It makes me suspicious and makes me want to pull C63 to see what happens to my signal coming out of this amplifier stage. Is something down the line dragging the signal? Now, remember, when you're looking at it, you can think, well, something's wrong. It's not amplifying right. Or maybe it's being dragged down by something. So let's just pull C63. It's not that hard to do. I'll pull C63, and then let's see what the signal looks like then. Are we getting the amplification we could? If it is, we know this is okay, and we've got to move on down the line. So let's get my hot tweezers out here. Let's see if I can get that C63 off of there easily. That's what these tweezers are for, so hopefully it'll work. All right, he's off of there. That quick, that easy. Now the question is, did anything change? So let's get this guy going. Let's put the signal in. Let's make sure we're getting our signal by checking on C66 again one more time. We're getting just what we expect. What are we getting over here now? Oh my God, off the scale. Yeah. Something's loading that section down a lot. Let me get a measurement here. Yeah, we're getting about around 900 millivolts. So about a 10. Let's see, what are we getting here? 100, and we're at about 900. So we're getting about a 9 to 1. So that makes total sense to me. That means that amplification stage is okay. Where's all my signal going through that capacitor? That's going to be the next question. Let me reset some stuff here, and we'll be back to continue on. Okay, here's what I've done. I pulled out the IT12 Heathkit signal tracer. I'm going to do a little tracing here. But most importantly, I went and found the PCB files for the LARCSET. I don't use KiCad or KiCad or however you pronounce it, but that's what the files were in. So I downloaded that. So it took me a little while, but I got downloaded, figured out enough to load up the design of the board, got it to turn everything off but just the silk screen, because these silk screen on this board is a mess. You've got they've got them over top of each other. They've got them under parts. Once you put the part on, you can't read the whole thing. It's very hard to find it. So what I did is I printed this. I highlighted the ones in the chain of the signal that I was interested in. You can see we come in the microphone in here. In each of these capacitors that are highlighted are coupling capacitors between stages, so I can step through the stages. I drew a line how the signal goes. It goes C66 through the amplifier, microphone amplifier, C63 over to C87, over here to C22, and then through the first crystal in the crystal filter to C21, C22 or 2019, and then C24 at the end of the crystal filter. Runs over to C28, over to C14, C30, C31, C53, C52, and then over to C46. And then from that, it drives the power amplifier. So we should be able to follow our tone as we go. We're going to switch from audio at this point to RF, obviously. We should be able to follow this through. Let's see how well we can do and what we find. Okay, so let me go ahead and turn this up some. I've got a 1500 kilohertz signal going through. I put on audio, and we're going to go C66 right off the microphone, which is being fed by my signal generator. So C66 is right here. Oh yeah, real loud. From C66, we need to be looking at C63 right here. No problem. C67 right here. No problem. Then we're going to go into the transformer. No problem there. We're going to come out. We now have RF fed on it. So I'll go ahead and switch to RF. We're going to come over to C29, which is there. Then C22, there. And from there, we're going to the crystal. So we should be able to pick it up on the other side of the first crystal at C21. That's the ground side. I can tell by totally silencing the. I think I might hear a tiny something in there, very little, but I wouldn't expect that crystal to knock it down that much. Looking at the board layout from C22 over here where I've got a good signal, we come to this side of the crystal. So let's see if we got anything there. Okay, so it's making it to the crystal. The other side of the crystal is almost non-existent. That's not right. Get you where you see. Going in the crystal this side, got a great tone. Got almost nothing coming out on this side. I wonder if I got a bad crystal. Could it be that? Could it be that easy? Could it just that be what it is? I tell you what I'll do. Before I remove the crystal, I'm thinking maybe what we do is, what if we pull C22 off and pull C24 off? So both ends of the crystal filter, the couplers, now the crystal filter isolated from the rest of the radio. Solder a little wire on both and hook up the spectrum analyzer and scan this and sweep this crystal filter and see what it's doing and see if it does what we expect or there's a problem. And if there's a problem, I'm going to assume it's that first crystal. At least that's where I'm going to start. So give me a minute to rig all that up. Get that. Okay, well, I had to take a break. Some stuff came up. So we're the next day. I got around to going ahead and finishing up, hooking up our wires for our spectrum analyzer to look at this crystal filter. And I've got it all set up over here. I've got it set to the center of the spectrum analyzer is 11.059, which is what the crystals are. And I'm charting out the crystal filter, and it's working. It's doing what it's supposed to be. It's not the most beautiful one I've ever seen. It's got quite a bit of ripple in it, and it looks like at best it's minus 4.63 dB, and it gets as much as -12. It ripples quite a bit in there. I'm gonna freeze this. You know, I'm thinking, since it looks like this is working, I'm thinking it seems to me that maybe our signal being put through is not in the pass band of this crystal filter, and maybe that's why I'm seeing such a reduction of signal. Let me go ahead and freeze this on here. Okay, I've got that frozen. Everything the same. We'll be able to see comparative to where the oscillator is falling out. What I'm going to do now is I'm going to disconnect this. I'm going to turn the tracking generator off, and I'm going to tap into the local oscillator for the mixer, and let's see where it's falling. It should be in that pass band. If it is, then I don't know what's wrong. I'm going to have to really scratch my head. If it's outside that pass band, I can tell you why the signal's being attenuated so heavily. The crystal filter is doing what it's supposed to. We say we only want these frequencies, but then we provided an oscillator outside of that, so of course it attenuates. So let's see what it gives. Give me just a minute. I will get that all rigged up, and then we'll go from there. Okay, I'm back, and I've got it hooked up to the local oscillator. I've projected on the second trace, and yes, our oscillator is outside the pass band of our crystal filter. Looks like our crystal filter is actually lower than 11059, and our oscillator, our local oscillator, is real close to 11.059. So anyway, let me do this. I threw a USB key into the spectrum analyzer. Let me grab a screenshot here. Okay, so I'm going to pop that up on the screen now so you guys just can see what I'm looking at. And you'll see, if you look carefully, the purplish color is our oscillator, very narrow oscillator spike, and you're going to see that it's missing the pass band. It's like 32, 33 dB down. Yeah, that would be a pretty dramatic signal loss. I think you'd agree. So I think what happened was somebody made a mistake when they were sorting the crystals. That means I've got to move one of these, and obviously the easier one to move would be the oscillator. I do have some 11059 megahertz crystals. In fact, I got a bunch of them, if you remember, and I've sorted through them. I should be able to find one that's a little on the low side and get into that pass band with it. Let me see what I can come up with. I'll do that off camera, and I'll come back and hopefully I'll find one. We'll pop that crystal out. We'll put the new one in. So we'll turn the trace back on. We'll see where it falls, and hopefully we can get it in that pass band. So, okay, I'm back, and here's what I ended up doing. I went through probably almost 100 crystals, found the one that pulled me the most lower frequency. It's this crystal. You can see the taller crystal put him in, and it brought me side of the pass band. And so you can see I've put it in that pass band. I'm happy with that now. What I'm going to do is I'm going to clean this mess up and get everything out of my way. We'll set up with our signal tracer, and we'll see if our signal is getting through the filter now, or am I just crazy and this was all for naught. Okay, I'm all set up, got the signal tracer set up. We're ready to go through this. I've got the signal and SIGGEN putting out same signal we were doing before. Let me turn the radio on. Let's see what we got coming in the mic. Ooh, big signal, big signal. I don't have this turned up a bunch more than what it was. Let's see over here at C22. Got to go to RF at that point because we went through the mixer and now we got RF. Oh man, big signal. Let's go through the first crystal. Oh yeah, baby. Oh yeah, baby. It's dropping down. We still got signal coming out. Of course, we expect it to lose some, but I wouldn't get anything through so I could turn this thing 100%. And if it was in there, it was very light. So the big question is, I could go through the whole path, but why don't we just jump? It looks like we've done something here. Let's jump over to C46, and that is the coupling capacitor into the power amplifier FET. So let me go ahead and get on it. Oh yeah. Oh yeah. We weren't getting that before. So I think we're getting modulation all the way through the system now. So definitely had a problem there. Definitely made a big difference. Now, that doesn't mean everything's working the way it should, but at least we're a lot closer. So that's a biggie. So let me rig up and start doing a little more testing to see, put the mic on, see if the voice modulation is getting through, if we're getting power out of the unit, all of the goody stuff. So I'll I'll be back in a few minutes and we'll see where we're at. Okay, I'm back. Went ahead and get everything hooked up. Give it a try. I do have output. It was very, very low. I was looking on the forums and found a bunch of stuff. I'm going to put up a couple here on the screen for you to look at. Turns out there's some mods. People are having the same issues. Not necessarily with the crystal issue I had, but they were getting low power like I was after I did the crystal. I did those mods. I rewound the bandpass toroids here to 21 turns. I played with it, tried a couple. 21 seems to be, to me, the best. And that brought the power up considerably. So yes, the bandpass filters at wound at 19, as the instructions say, are outside the frequency and causing issues. So I did that. That helped. I did the mod for the microphone I've got up here. That boosted the modulation some and helped. And here's where we're at. I've got the current now up here on the Keithley, and I've got my watt meter up here so you can see it. And I'm going to go ahead and turn this thing on. I've got the mic hooked up. We'll hook up the key and try it, make sure it's working okay too. But let's get the power on. I've got the spectrum analyzer, got a wire wrapped around the coax running to the watt meter, so we can see where we're at on frequency. So there we are. We've got our, roughly, we're running about 96 milliamps unkeyed. I'll key quietly. We got about 350 milliamps as requested. Let me give my best little holler and whistle here. Let's see what kind of power on the watt meter we can get out and how much current we pull. Audio. All right, so we're getting about 2.5, pushing 3 watts. That seems to be pretty good on the forums for what people are getting. That's about what they're getting out of it. So let me do this. Let me turn it off and hook up the key, and we'll make sure that we are transmitting CW. Everything's working with that. Turn that on. Oh yeah, we're getting our about 2.5 watts. So here's what I want to do. If you can see the signal spectrum analyzer over here, I'm going to key down, hold it down. Let's see what our frequency range is. Okay, that's 7.024 right there. I'm going to go on up. Going to go on up. 7.285. So the highest frequency 7.285, and the lowest frequency is 7.024. Not bad. Pretty happy with that. That's most of the band. I mean, that's pretty well the whole 40 meters, which I wasn't expecting. That's not. This is supposed to be, give you just a little part of the band. It's not supposed to give you that much. So I don't know why mine's doing that. I mean, I kind of tuned it a little, but I didn't expect that. So anyway, we're putting out what we're supposed to be putting out. So I hope you'll tune in to my next video in this series. I don't know if it'll be the next video I do or whether it might be a couple videos away, but we're going to mod this and get this to be a little better. My overall opinion is it's a neat concept for a kit. I think quality control might be a little bit of a problem with it. They designed the bandpass filter so tight. If you're not perfectly on, and that's where we were getting in problems with needing to rewind these torads, everybody's little variations could be a problem. If the bandpass was a little wider, we had a little room for error, it would make the build easier and not as concerned about building and it not working. The crystal mismatch I had, for example, if you're a beginner and you want to build this and you build it and you have the same issue I had where that one crystal was off enough that it put your local oscillator outside the crystal filter, without some knowledge and some equipment stuff, your beginner's going to be challenged. This would be a radio they just couldn't get working, couldn't get it transmit. That would be sad to see, because that tends to make people not want to continue on. So a few quality control things could be done. Another thing about the radio, let me see if I can get it to do it, that I don't know I can do anything about. I don't know if you can hear it. Let me put the mic over there if you don't mind. Let me get where we got nothing transmitting. Okay. Listen as I tap. Are you hearing that? They've used a lot of ceramic capacitors, a lot of them. And I think they're like low buck, cheap you can get, trying to keep the cost of the kit down to the point that we've got a lot of microphonics going on in here. I believe it's from the ceramic capacitors. And it's not going to be like one or whatever. It's going to be a number of them, but it's got a lot of microphonics to it. You really want this thing mounted solid and not being bumped around, because anything you do, it's generating that into your audio. So that's another little thing I don't think there's anything we can do about. I don't see us doing anything with that. That's where we're going to go from here with this. So thanks for hanging in on this series. Hopefully you'll come back to see what we end up with on the modifications. I enjoyed your company with me as we work through these problems. I hope you learned a little something. Hope I entertained you some. I hope you'll hit a like button if you enjoyed it. Really does help me out. And most of all, I hope to see you in my next video.